Hello guys, welcome back to Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. In today's lecture, we are going to determine the centroid of this I shape. So we can find out the centroid of any shape by the simple formula that y bar is equal to the summation of areas into the centroid of each object dividing by the summation of areas. So by this formula we can find out the centroid. So the I shape centroid will be somewhere here, at this point from the bottom. So this will be known as the y bar, and we have to find out this y bar from the bottom of the I shape beam. Now for this we need the areas of each object, the centroid of each object. So let's consider this is the first object, and let's suppose this whip is the second object, and this top flange is, let's suppose, the third object. So we have three objects or three different shapes. In each of these shapes we have to find out their areas and their centroid from the base of the plate. So to start first with the areas, so let's find out the area of A1, the first object, which is this one, this object. How to find the area? We are known with the dimension 80 meter and 200 millimeter. So this is the area of the first object, which comes out to be 16,000 square millimeter square. The area of the second object, similarly, 330 millimeter is the width and 180 millimeter is the height. So 30 into 180, it comes out to be 5400 millimeter square. The area of the third object, which is this one, so the length is 100 millimeter and the height is, or the depth is 50. So 50 into 100, we got here 5000 square millimeter. So these are the areas of each object. Now to find out the y. What is mean by y? It means the centroid of each object from the bottom plate. We want to find out the centroid from the bottom, is y bar is from the bottom. So it means if this is the y-axis, remember this is the y-axis. That's why we find out to the centroid about y-axis. This is y-axis. So we want to find out the centroid along the y-axis. So the first y will be the centroid of the first object, y1, which will be equal to the, if I draw it with another shape, so it will be the centroid of this object will be here somewhere, which is 80 dividing by 2. This will be y1. 80 divided by 2, which comes out to be 40 millimeter. The centroid of this second object, it will be from the bottom, so it will be y1, sorry, not y1, the total height of this first object plus the centroid of the second object here up to this point. It means y2 will be equal to this total height of the first object, which is 80 millimeter, plus the half of this one, 80 millimeter, because this is the centroid. So 180 dividing by 2. So here we got here 170 millimeter. 170 millimeter is the centroid of the second object. In the similar way, to find out the y3, the centroid of the third object, we have to start it from here, bottom plate, which will be equal to the depth of the first object, and then the depth of the second object, and then the centroid of this third object, which will be 50 divided by 2. So here, so this is the centroid of the third object. So it will be the depth of the first object, which is 80, the depth of the second object, which is 180, and then the depth, the half depth of the third object, which is 50 divided by 2. So by adding these values, we got here 285 millimeter. So these are the centroid of this object. Now we can easily put into the formula, into this main formula. So y bar will be equal to the, here if I expand this formula, so it will be summation of a1y1 plus a2y2 plus a3y3 dividing it by a1 plus a2 plus a3, because it is the summation of area and it is the summation of the product of the area and the centroid of each object. So now we know that I have A1, Y1, A2, Y2, A3, Y3 and the A1, A2, A3. So we can simply plug these values into this formula to find out the centroid along the y-axis. So A1 is 16,000. So I'm just putting all these values here. So and then A2 5400 and 170 plus 2, and then 5000 into 285 dividing by the A1. A1 is this one, A2 is this one, and A3 is this one. $5,000. Now by simplifying this, we got here something like this value, which is a big value, 2983,000, dividing it by 26400. So this is the simple value that we got. Now after dividing this, we got a value of 112.99 millimeter. So it means the centroid of this object here is 112, almost 113 millimeter from the bottom of the plate. So this centroid is equal to the 112.99 millimeter. So this is the way how to find out the centroid. You can also find out the centroid of any complex object, for example like this shape, L shape or any shape, just by using this formula. Hope you guys understand, and don't forget to subscribe our channel for daily civil engineering videos. Thank you for watching our video.